Right, so today we're going to be looking at graphing proportional relationships. And when you have a proportion or two rates that are proportional and you want to graph some data, what you're going to notice about proportional relationships is they will be a straight line through the origin. So let's get to show you what that looks like. So the graph of a proportional relationship will start at the origin, and it will be a straight line. And one of the characteristics is, if you notice that on your independent variable, this point here would be 1, comma, whatever your slope is. So m is what we call slope. So in a proportional relationship, the unit rate would be visible in the coordinate where you have your x coordinate of 1 and your y coordinate would end up being your slope. So the equation of it will look like this. So the equation of a proportional relationship will be y equals mx. In this equation, m is going to be the slope, or like I mentioned before, it's actually a unit rate if it's a real-world application. Okay, so let's look at an example. All right, so let's look at graphing this proportional relationships that involves paying for an X number of gigabytes. So let's look at example 1. The cost Y or the cost Y of X gigabytes is represented by the equation y equals 10x. So we're going to graph this and interpret the slope. And that just means we're going to try to see what relation the slope has to this whole problem, what it means. So if we want to graph this, we're being told that the price we pay is going to be y, and the number of gigabytes we want to purchase is x. And this equation here tells us how much we're going to end up paying. So say I want to buy 4 gigabytes. 10 times 4, that means 40 bucks. If I want to buy 3 gigabytes, that'd be 10 times 3, 30 bucks. So we're going to put the graph that represents all of those values. Say this is x, and let's make this 1 gig, 2 gigs, 3 gigs, 4 gigs. So we'll just say this is the data in gigabytes. And on the y-axis, we'll have the cost that we pay. And we'll say in increments of 10. 10 bucks, 20 bucks, 30, 40, etc. So to put this on the graph, you can make a t-table. And I know that my y is going to be given by multiplying 10 to the x. So let's just choose the smallest number, 0. 10 times 0 makes 0. So the point 0, 0 is on my graph. That's this point here. 1, 10 times 1 is 10. So 1, 10 is on my graph. So if I continue, that's what it would look like. Straight path through the origin. So we already know it's proportional. We have a constant rate of 10. And we want to interpret what the slope means. Well, what is the slope of this line? If it's not obvious, let's recall. Slope is given to us as the change in the y divided by the change in your x's. Visually, you create this triangle and you record the height and the width. So from here, it looks like it's from 0 to 10. That would be 10. So we would travel to the right and then up. This would be 1. And this would be 10. Now, we're not counting the blocks because it's a very common mistake. What you're doing is you're looking at the scale on the axis. So if I'm going from here to here, that's 1 unit. And if I'm going from here to here, that represents 10 up. So my vertical would be 10, my horizontal would be 1, and therefore my slope is 10 over 1, or just 10. Now if I put the units in, that really means $10 for 1 gigabyte. So what does the slope mean? It says right here, interpret the slope. So we're going to just say that the slope, $10 per gigabyte, which actually is equal to the unit rate. And remember, unit rate means how much it is for one of something. And there you go. So the slope, interpreted in this problem, represents the unit rate or the price per gigabyte. That is your slope. And it's evident. 1 more gig, $10 more. 1 more gig, $10 more. 1 more gig, $10 more. So indeed, the slope of the line, which is the staircase going all the way up, would be 10, 1, 10, 1, 10, 1, which is the cost per gigabyte. And there you go. Let's look at example 2. This one's referring to 2 ski lifts. So when you're going skiing, you got to go up the mountain, and you got to have a ski lift to take you up the mountain with all your equipment and gear. So a 2-person ski lift takes you up at a certain rate. And then we have a 4-person ski lift that takes people up at a different rate. So obviously one is faster, one's slower, or maybe the same speed, who knows. But we're gonna try to figure out, of the 2 ski lifts, which one's faster? Which one will get us up the mountain faster? So the data given to us for this 2-person ski lift is in a graph. And we're going to say this is 1, 2, 3, 4, 5, 6, 7, 8. And that represents seconds. The amount of time we're on the lift taking us up the mountain. And the distance would be on the side. And that will be in meters. So I'm given that after 2 seconds, our distance is 4. 2, 4, 6, 8, 10, 12. So I would be 2, 4, And then it says that after 4 seconds, we are 8 meters. And so connecting those lines looks like this. So after 2 seconds, we were 4 meters. This point means after 4 seconds, we're now 8 meters. And then the 4-person ski lift, the information is given to us as an equation. So this graph shows us the rate at which we're going up the mountain on a 2-person ski lift. This equation shows us the rate at which we're going up the mountain on a 4-person ski lift. Y is still distance in meters, and this is going to be our time in seconds. So, which one is faster? That's the question. Okay, so we want to go up the mountain, obviously the fastest, so we don't waste any time. And how are we going to find out which one's faster? Well, we can find out the rate. So to find the rate, we already know that it's equivalent, or the unit rate is equivalent to the slope. So the slope, again, is going to be the change in y, change in x. So I see that I've gone 4 is my vertical distance here, and then my horizontal distance here is 2, which means it's 2. So it's 2 meters for 1 second. So 2 meters per second, that's the lift for a 2-person ski lift, or the rate for that ski lift. And now I want to find the rate for the 4-person ski lift. Well, if I'm given an equation, and remembering that this equation, this is your m, that's your slope. So I can already say that that's my unit rate. The slope is the unit rate. Because of the way it is in the equation, that is my unit rate. So therefore, I can conclude that the 4-person ski lift is faster. And again, I know this because the slope in any proportional relationship is going to be the unit rate when it's applied in the real world. All right, let's look at another example. Now I'm going to ask you to put both of them on the same graph. This was the 2.5 meters per second. This one was the 2 meters per second. And so now you can see that if we compare them, what do we notice? The faster lift is steeper. So when you have a slope with a larger value, it's going to be steeper. And when you have a slope that's a smaller value, it's going to be, well, not so steep or flatter. So that's a general rule too. The larger the number, the steeper the line, the more vertical it looks. So that's how we graph proportional relationships.